Good morning, good afternoon, and good evening for all of you. Why I am telling this morning, good afternoon, good evening, because I don't know which time you will you will see my that this video. So actually, yesterday I told about that brief definition of simple harmonic motion, and there I told about what is mean position formula, so and what is extreme position and what is the equilibrium position I told, and also I told suppose what is difference between periodic motion and oscillatory motion. So today let us will start further. Okay, so today I will tell about example of a simple harmonic motion, right? So I am writing here, see, example of simple harmonic motion, that is example. So best example I will write here. I will take example like simple pendulum, that is one string here, one point mass present, and that is fixed here now. That is string length L, and that is point mass. Point mass of mass suppose m. So initially I told that is present at point A. That is present at point A. So if that will be tension now, and that is mg. So can I tell at point A, tension equals to mg, correct? That is a mean or extreme till now. That is mean position. Okay. Now I applied force, some impulse, so that it will now oscillate. Like suppose I applied force like that, so it will go here now. It is going here now. That is point B, and that angle is theta. Further, it will come back toward its mean, and same angle it will subtend here also. Got my point? I applied force, and this will go A to B. Further, it will come B to A. Next, it will go A to B here now, and further it will come toward its mean. And this will happen means many times, not only one times. Okay. So that angle also will be theta. Okay, this angle theta, this angle theta. So what is simple harmonic motion? Actually, in oscillation, I told in oscillation, what I told, force equals to minus k x power n. Okay, oscillation. Okay. So n equals to always that will be 1 3 odd number. Why odd? In comment box you tell why odd only. Okay, odd number. So in case of simple harmonic motion, in SHM, f equals to minus k x power n, and n value equals to 1 here. That is important thing, all of you. N value will be 1 here. Okay, n value will be 1 in case of simple harmonic motion. So here we will get what formula we will get? F equals to minus k x power 1. That is our simple harmonic motion. Okay. Many books you will check there it has given f equals to minus k into x. That is also correct. That is I will be checking that video is visible or not. Yes, it is visible. So that is see here now. That is mean position, right? That is mean position. That is extreme position. Got my point? And that is also extreme position. Got my point? Okay. Up see here now. At this point, so for simple harmonic motion, I am writing here one note. For simple harmonic motion, angle will be very less. Means less angle, not 20 degree. I told this angle tell for simple harmonic, so that will be very less like that. Okay. But generally this angle will be like 2 degree, 4 degree, 5 degree, 6 degree, 7 degree. So generally that angle is less than 10 degree. Got my point? So it will be now simple harmonic. Suppose I told I have one simple harmonic motion, means simple pendulum, and that is oscillating 30 degree, means that is mean, right? So here 30 degree, mean 30, mean 30 degree, mean 30. That 30 degree, it will be not a SHM, it is a oscillation. Got my point? SHM only for very small angle. I told that angle limitation, right? So now at this point B, just I want to write, means I want to draw FBD. So here that is tension, right? And here that is mg. Correct my point? Now this is, see, that is angle theta, and this both are parallel, check. One minute I am showing you. This both are parallel line. So if this angle theta, so this angle also theta. Correct my point? So tell how many means that components of mg, that will be mg cos theta. Now that will be mg sin theta. So at point B, tension equals to, tension equals to mg cos theta. You know that mg sin theta, actually what is problem here? At this moment, this mg cos theta and tension both will be opposite and equal, but they will cancel out, right? This mg sin theta, due to this force, your particle wants to come toward its mean position. Got my point? So this mg sin theta is called restoring force. Got my point? So actually this is a restoring force, and due to that restoring force, your particle, this particle wants to come back toward its mean position. And that is mean position, that is extreme here for it. Now this, due to this force, this will come here. So you know what is problem? That is a mean position, right? So I will tell that is 0, 0. And you know this angle is very small. So this arc length also very small. If angle very small, so arc length very small. If you have doubt, so here I will show that, see what is problem here, see. That is actually, that is theta, right? So that arc length, it will treat it as a, you can assume this is straight line. That is very small angle, okay? That is very small angle, very small. So that length assume x, and that length assume L. That is mean position, right? That is mean position, and that is extreme position. So that is actually origin, assume mean position, starting point, origin I told. So if your particle is going toward extreme, that is positive direction. I told, okay, that is positive. You can take negative also, no doubt. Yes, I told positive, assume. So at this moment, your restoring force will be this, that is mg sin theta. So can we write that restoring force equals to mg sin theta, but here minus. Why minus? Because that is the direction of, suppose that is positive direction. Suppose that is positive direction. So restoring force, that will be opposite of restoring. Got my point? That is mg sin theta. So it will be opposite direction, right? That is minus x. Mg sin theta and minus x. So force is actually vector quantity. So if I am writing that force value, so I have to denote that negative sign also. Okay. Let us now, we will start here that derivation. What is force value? Tell force value. Yes sir, that is now mass into acceleration equals to mg. Just I wrote here this mg sin theta. Got m cancel out. A equals to minus g. You know, sin theta actually, if theta very small, so sin theta we can write as a theta. Actually, I am telling everything here. If theta very small, so sin theta we can write as tan theta, and that is also we can write as a theta. And see, suppose this angle x, this length x, this is L. So what is tan theta? That is x by L. Okay. So here we can write that is x by L. So acceleration equals to minus g into x by L. Now I am asking one question here. Now I am asking one question. This g is constant, right? Because 10 meter per second. This length of a simple pendulum is also constant. So here just we have to focus on acceleration and x. So can you write acceleration that is directly proportional to minus x. So that is a simple harmonic motion. Means that due to this formula, due to this means this theory, a equals to minus x, we can we can prove any simple harmonic motion, right? Many question you will get. Just I'm writing that question also. So I told you this f equals to minus k into x, right? And f equals to what I told, m into a and plus kx equal to 0. So can we divide by m in both terms? Yes. So we will get a plus k by m into x equal to, here I divided by m everywhere. So m a by m cancel out a. I will not write that thing now. Okay. So this is a simple harmonic motion means formula. So a equals to, here expression, right? A. So we know that is a d square x upon dt square plus k by m into x equal to 0. See here now, that a, we can write here d by dt also and v d by dx also, but here actually x present. So I told just this value write as a function of x now. So this is a d square x upon dt square plus k by m into x equal to 0, right? So that is, got my point. So d square x upon dt square plus that k by m is nothing but omega square x and equals to 0. This remember, got my point? Remember one thing, all of you, that omega equals to k by m under root. Okay, on that I am writing once again that k by m. What is the mass of that given block or object, right? This k is a spring constant. This k is spring constant. And what is this? Angular velocity. Got angular velocity. So this formula remember. Okay. Just a simple thing I am telling. Very simple thing. X equals to a sine omega t. Now tell this is simple harmonic motion or not. Suppose I don't know this is simple harmonic motion or not. This is simple harmonic motion. So I will prove by using this formula. Suppose in many questions I saw in Siemens advanced neet also one question given like x equals to e power iota x, till that is simple harmonic motion or not. Got my point? So we have to prove this now. So here x equals to a sine omega t present, right? So what is velocity? That is dx by dt. See, this is first question, so I am explaining in depth. That otherwise further you can means fastly you can solve by using this formula. So I am writing every concept here because that is first question. So v equals to dx by dt. So here tell x is what? A sine omega t upon dt, right? Here see A, that is constant, you can take common, and sin omega t, what is omega cos omega t, that is our velocity. Next I will calculate acceleration, because finally what I want, acceleration, right? So that is equals to minus A omega square sin omega t, right? Because that omega is common, and what is the difference of cos omega t, that is minus sin omega t into omega, so omega square, right? Now I got this, and what is our that theory tells about simple harmonic motion, a plus omega square x equals to 0. Put here a value, so that is a omega square sin omega t plus omega square. What is x value tell? X value a sin omega t. See here, minus a square sin omega t, minus here plus now, plus a square omega sin, that is equal to 0. It means that is a simple harmonic motion. Next question I am writing, suppose given x equals to cos 2 omega t. Now we have to prove that is simple harmonic motion now. No, proof now. Tell, answer. Video, good. So same thing I will apply here. X equals to what? That is minus 2 omega, right? Here minus 2 omega sin 2 omega t. Got it, right? Cos 2 omega t is minus sin 2 omega t, and outside 2 omega, because that is chain rule. Next I will tell you about acceleration, that is equals to minus this 4 omega square and cos 2 omega t. Got it, right? This 2 and 2, 4 and that omega square. That is our acceleration. So now further I will use this same formula here, writing a plus omega square x equal to 0. So put a value, so that is minus 4 omega square cos 2 omega t plus omega square cos 2 omega t equal to 0. Check now. Check here. See this, minus 4 omega square cos 2 omega t plus omega square cos 2 omega t. That is 0. No, that is not 0, because here minus 4 omegas are present. Check first here, this here only 1%, here minus 4%. So if you will add both, you will never get 0. It means that is not simple harmonic motion. Not getting my point. This is not simple harmonic motion. Good. Otherwise you have doubt, sir, I want to write one thing. Sir, a plus many students asked in class also, so I am telling. A plus omega square x equal to 0, sir. That is our means theory, our formula, our concept. So can we write a equals to minus omega square x? Yes, we can write. But what is a value? Put that a value, minus 4 omega square cos 2 omega t. And here what they told, sir, a directly proportional to minus x. Yes, that is correct. I am telling that is concept correct. But here if you write that thing, minus 4 omega square cos 2 omega t, and next equals to minus omega square, what is x value? X value that will remain cos 2 omega t. So what they told, sir, this a is a, no, that is not correct, because here we are not getting 0, that is non-zero, because here minus 4 omega square, here 1 omega square. So this type of question also you can get in your exam, right? So next I am telling. So if I will write summary, so oscillatory motion means that is one simple harmonic motion, and another is uh, non-simple harmonic motion, non-SHM. Okay. So here I told sir what is that value. So A equals to minus omega square x. No doubt here. Huh? Non-simple harmonic motion is what? See, suppose you have one floor. No, that okay, floor. Here one floor present, and that floor is frictionless. Just that is ideal case. Okay, now. Now here what I told here just I I have one ball of mass m. Got my point? Now I released this ball. So here it will go up or down? Yes or down, because due to gravitational force. I released, that is going down now. I told here E value 1. What is E value? E value is the coefficient of restitution of that elastic collision. So if E value 1, so there is no loss of energy. It means what is meaning of no loss of energy? If E value 1, suppose your velocity, suppose this height is h. So here what is velocity? 2gh under root. So it will rebound, it will come back now, it will reflect, right? So it is going now up. So same velocity. Got it? Suppose it is going with a 10 meter per second here. Suppose it is colliding here 10 meter per second. So 10 meter per second it will go up also. No energy loss. Got my point? So this is what is find the case that is going down, coming up, going down, coming up, going down, coming up, going down, coming up. Got my point? This oscillating. I'm asking that is simple harmonic motion or not? No, because here this E value positive means that is a variable or constant. That is variable because this acceleration depends on x. What is x? Mean position. Suppose your mean position. Now block going means x value increasing. So acceleration also increasing. Got my point? Means acceleration variable everywhere. Variable. But here acceleration everywhere constant because that acceleration value here g. So here E value equals to minus 10. That is not a simple harmonic motion. Not simple harmonic motion because that is constant. That is the case of non-oscillatory motion, right? So next I will tell about that spring block system of that is also very good example of simple harmonic motion. And here I will explain everything about that simple block system. See, that is spring, that is mass m%. I told that mass m, right, and that is our mean position. That is mean because that is natural length position. That is mean position. What I meant? Here one block I kept and I fixed this spring, and that is frictionless. Okay, frictionless or smooth surface. Frictionless or smooth surface. Now I applied force. Initially this is now in rest. No, it is not moving. So I applied force. So due to that force, it will oscillate, like it will expand. It will expand or it will compress, no doubt. Suppose it is expanding, so it will come back once again. It is going like that. It will oscillate, right? It will oscillate. So suppose it is going here now. That is extreme position, and further it will come back toward its mean position, and further it will go here also. Many students will ask, sir, why it will go further here? Because see, what is problem actually? See, I will see. Suppose that is a simple pendulum, and that cap you can assume mass. So initially tension and mg, equilibrium, rest. Okay, now it is going. Suppose here, suppose this angle theta. Here theta. So here going. Now it is coming. So it cannot stop here because due to from here it is coming now. So here it is coming. So due to inertia of motion. What happened? Suppose here going from rest like that mean position, not rest, mean position. So it is going toward extreme. What happened? Now it is coming. So it will not stop because due to inertia of motion, it will continue its motion further opposite direction. because here actually all kinetic energy is converted into potential, and from all potential now converting into kinetic. So here this block will get kinetic energy, and due to kinetic here velocity percent, so this cannot be stopped, it will go further toward opposite direction. Got? So if you go here, that is also called extreme, that is extreme, and further it will come, and it will not stop here also, it will go like that. Got it, right? So I have to explain at mean what is see at mean. Just I'm asking here, tell it is here velocity, but you will tell sir here velocity is 0. Don't remember everything. See here velocity 0. Got? And that is, you know, mean to extreme is called amplitude, and amplitude is at maximum displacement. That is suppose plus a. So I told there a equals to minus omega square x. So what is the value here? Sir, minus omega square a. Here also, what is the value? Minus omega square a. What happened? You tell if velocity is 0, what about kinetic energy? What about kinetic energy? I think 0, because half mv square is 0. Now you know mechanical energy, I am writing here, mechanical energy that is called potential plus kinetic. So if kinetic energy is 0, so potential energy maximum. What? So calculate here now, potential energy equals to nothing but that is maximum. Till here, till at mean position. At mean, you know, here velocity maximum, because if particle is going from mean to extreme, so suppose the motion is plus x, assume that motion is plus x, but you know restoring force, due to restoring force, if particle is going plus x, so restoring force opposite action. Why opposite? Because restoring force always wants to come back toward its initial or that mean position of your particle going, so spring expanding now, but restoring force does not want expansion, that want only natural length. So expanding, so it will come back, means force will be opposite. So that is the force direction toward negative x direction, right? That is restoring force. So here that is accelerating or deaccelerating? Deaccelerating, not accelerating, because motion is plus x and force means minus x. Acceleration also minus x. Deaccelerating. So it is becomes 0 now at extreme. So what I am telling here, V maximum, so kinetic energy also maximum, right? And potential energy is 0. Same thing will happen here also. What is the velocity value? 0. So kinetic energy equals to 0 and potential energy equals to maximum. I think you are getting my point. So if I am telling if a particle is going from mean to extreme, so force is variable or constant? Force, so it is variable, because force equals to minus k into x, and x will increase, so force also will increase. Got my point? So mean to extreme, force will variable, next velocity will decrease, next acceleration will increase, next kinetic energy will decrease, next potential energy will increase. And one thing, what is time period? I am writing here what is time period. See, here actually too much things I have written, so just that is mean, that is extreme, next further that is mean, and further here one extreme, and further it is mean. See, that is called one time period. See, first it will go mean to extreme 1, next it will come extreme to mean 2, next it will go mean to extreme 3, and next it will go extreme to mean 4. You know, that is called, suppose that is point A, so finally it will come towards point A, so that is called one time period. One complete oscillation. So what is the meaning of complete oscillation? See, that is mean complete oscillation. See, if further it will come toward its mean, then it is called one complete oscillation. How see? That is mean, so it is going, okay, further, further, further. Then it is called complete one oscillation. You have seen in your home that simple pendulum clock. So suppose this is a simple pendulum clock. So how many means what is the time period of simple pendulum? Tell in comment box. So suppose that is 1 mass per second, and now I told, okay, now starting that oscillation, see, that is mean, right? That is extreme. Due to inertia of motion, it will continue its motion. Here mean, here mean extreme, mean extreme, mean extreme, mean extreme, mean extreme. So what is that time period? See, mean, extreme, mean, extreme, mean. That is called one complete time period. Okay. Now I will tell about phasor. You know, many times I saw one graph problem also, minus k into x till suppose I have to denote here force versus displacement till which type of graph. So that is I think straight line, you will tell. So we can write in place of force we can write y, okay, that is y equals to minus in x, means slope negative, right? Slope negative means third and fourth quadrant. So that will be a straight line, and that direction means that is called tan theta, and tan theta equals to minus n, right? Minus actually k, right, directly. K is force constant, that spring constant, right? Next one question it has given about acceleration versus x, like that a equals to minus omega square x, and that graph present, that is a and that is x. Now tell this type of graph, I think this is also straight line graph, okay, because here constant is negative, right? So negative means it will pass through this second and fourth quadrant, and I am asking till what is this angle, so that is tan theta equals to minus omega square. I think up to here we have no doubt. On v versus x, I am writing here what is very important formula, v versus x. What is that formula? Okay, so very simple thing. See, what is the a value? You will tell sir a value, that is minus omega square x. Got the point? See, actually I want a velocity. Or you tell in place of acceleration what you have to write, so that I will get here a velocity after integration or differentiation. We don't know that thing. So in place of acceleration we can write dv by dt, and another option we can write v dv upon dx. I will tell, suppose I will write this dv by dt, no doubt I will get the velocity, but time is variable and here x is variable. Means you are thinking here x variable, here time variable, here v variable, three variable here. Now if I write this, so v variable, okay, here x variable, but here also x. So here x, that value differential equation, that is x form, in form of x, in term of x. Here also that I will write d by dx, that is also terms in terms of x. So that is more preferable, that is good, that is not good here, I cannot get that answer. So I will write v dv by dx equals to minus omega square x. Now in differential equation variable separable, so this dx shift there because here already x present, right? So we can write v dv equals to minus omega square x dx, or integrate. Doubt, sir, what is that limit value? If x equal to 0, what is velocity? Sir, velocity will be maximum velocity. And here x equals to suppose plus c, what is velocity, sir? 0. Otherwise, you do one thing, here x equals to x, just random. Here write velocity v. You know, this is not correct. Why? Because both limit variable. I don't know what is this v maximum. 1 meter per second 2. I don't know this. This is also variable. I know that is maximum, but that is variable. Got? So what I will use? I will use extreme limit x equals to plus a. There velocity will become 0, and x equals to x, velocity v. That is one general formula I want to derive. So I wrote x and v. Got my point? And here x equals to 0. Of that you know, this is this you know, right? If this you know, so that you can derive now. So very easy now. What is v dv? So that is v square by 2 from 0 to v equals to minus omega square. That is also x square by 2, and that is what? A to x. So you do one thing, this 2 to cancel out, no doubt. Okay. Next, v square. That I put v square and equals to minus omega square, and that value x square minus a square. This minus shift here now means inside bracket, so omega square, and that is omega square minus x square, and v equals to omega under root, that is a square minus x square. Okay, v equals to omega under root a square minus x square. So that is our very important formula. That please remember for mains and advanced both. Okay, that formula. Okay, that formula. Okay, I'm checking video is going on. Okay. See, many times it asks what question, v equals to omega under root a square minus x square, v versus x plot. Velocity versus displacement plot is which type? How can we tell? That is, suppose that is going right, mean to extreme, extreme to mean, mean to extreme. That is oscillating. So that is which type of equation? Means which type of graph will get velocity versus x. So I am doing here now. You check please. V upon omega equals to a square minus x square in the root. Take square both side. So what you will get? V square upon omega square equals to a square minus x square, right? So further v square upon omega square, and do one thing. This shifter, this fraction x square equals to a square, right? So now I am telling divided by a square both side. Divide, that is constant, so you can divide. Okay. So v square upon omega a whole square plus x square upon a square equals to 1. You tell that is which type of graph. You know, I am telling you, see, x square upon a square plus y square upon b square equals to 1. That is, you know what? Ellipse. Ellipse, right? So if a more than b, a is more, greater. So that is a horizontal ellipse. That is horizontal ellipse, and that value plus a, that is minus a, that is plus b, that is minus b, horizontal. Similarly, x square upon a square plus y square upon b square equals to 1. If b more than a, this value. See here, this y now, this is y, of that value more, means y value more. So y more means that is vertical ellipse. Got my point? And similarly, that is a plus b, and here that is a minus b, and that is plus a, here minus a, no doubt. Okay. If given x square upon a square plus y square upon a square equals to 1, that is circle. Okay. Suppose given x square upon a square minus y square upon b square equals to 1, that is parabola. So every concept you remember please, because many question you will get related to that conic section chapter in mathematics. Okay. So wait, here I am telling this. Okay. So we have to draw v versus x. I am writing here. That is velocity and that is displacement. Now you tell. Along y, actually here y present, right? Here y present and here x present, right? Just I'm asking, this is y now. That is x, right? That is x and that is y. But in place of y, velocity present. Of this value rate, which is more? This a more or omega a more? I think omega a more. Means you denominator of y component more, huh? This y. So this will be more. This y, this is more, right? Check. This more. It means that is vertical or horizontal ellipse? Vertical ellipse. So you can denote as like that. Vertical. This value what tell? Tell this value. This value only. Plus omega a. And this is what? Minus omega a. And that is plus a. And that is minus a. What my point? This is so we can write v versus x plot will be ellipse. Okay. Suppose many times asked which ellipse, horizontal or vertical. So we can write here vertical ellipse. Okay. So equation of simple harmonic motion. Okay. So here x equals to a sine omega t. Otherwise you can write y equals to a sine omega t. So this is in which particle started motion from mean position. Means you can write t equal to 0, x equal to 0. Many times I checked in class also, classroom. Suppose given x equals to a cos omega t. Suppose many times given a sin omega t. So it ends confusion. Sir, x equals to a sin omega t, that is from mean or from extreme. What is problem? What is meaning of mean or extreme? Suppose I told this is a simple pendulum, here that is mean position, right? And now that is initially t equal to 0, it is present. Initially here present. So I just applied force, now it is oscillating, no doubt. Of that I told okay, tell equation. So that is equation now, a sin omega t. Or a cos when, see. Suppose that is extreme position. So just I kept by using my fingers, I just kept here and I released. If I release, it will go now. Got my point? So in this case, what equation? T equal to 0 here present at extreme. So that thing I am writing here now. That is 1. And 2 is if t equal to 0, particle present at extreme, that is extreme is what? Plus a or minus a? Plus a or minus a, no doubt. So x equals to a cos omega t. A cos omega t. Got my point? So generally, what we will write x equals to phi x, because many times it is x is what? That simple harmonic motion along horizontal. Y is what? Simple harmonic motion along vertical. There no doubt. Okay. So x equals to a sine omega t plus phi. That is a general formula. So what is x? Displacement from mean position. What is a maximum displacement? Thank you so much.